So what I'll do, I'll save as, okay, so I'll make a uncracked model. This was my uncracked model, right? Uncracked revision 1. So I'll make it uncracked revision 1.1 because I'll be showing you the construction sequence analysis in this structure. That's why. So I'm making another uncracked model with revision 1.1. This service cracked model will be using again, but now I'll be creating this uncracked revision 1.1. Click on save. I'll select all the beams, select object type, beams, and I'll remove all the stiffness modifiers. So assign, frame, property modifiers, I'll keep everything 1, apply. Close. Now we'll click on floors, select, assign, shell, stiffness modifiers, I'll keep everything 1, apply. So what we have done, we have changed, or you can say we have removed whatever modifiers that we have provided. If you right click here, there is no modifier you can see. Okay. Now I'll show you how we can do auto construction sequence analysis, or you can say construction sequence analysis in this structure. Okay. So to do the construction sequence analysis, just remember these steps. First of all, we need to go to define and click on auto construction sequence case. Auto construction sequence case means it will automatically create the construction sequence. Okay, so there it will not consider the effect of creep and shrinkage. Okay, so what we will do, we will create this first. I'll make it case is active. Okay, case is active. I'll take this self weight with scale factor of 1.5. Why 1.5? There are two processes. What you can do, you can consider self weight of 1.2 and live load of 0.5. Okay, or otherwise you can directly go with a higher scale factor for the self weight itself. Okay, so what is the need of this? I'll be explaining in a while. I do not need all these things. I'll just click on OK. I'll go to define and load cases. Here you can see this auto sequence is there. I'll make a copy of this, add copy of case, and now here I'll name it creep for suppose how many years? Maybe 50 years. Means after 50 years of loading, what will be the deflection of your structure? You can check here. So I have named it creep 50 years. So what is the need of this defining the auto sequence analysis? This particular thing, this stage naming, this duration column, okay, these numbers, and if you see the stage operations, this will be added automatically. This will be added automatically in this case. Okay, so that's why just to create this particular load case, creep 50 years, so that we do not have to do this by ourselves, I have defined this auto sequence. Okay, I'll click on OK. Now I'll delete this auto sequence. Okay, click on OK. To delete this, just define auto construction sequence, uncheck this and click on OK. Now if you go to define load cases, you will see we do not have this auto construction sequence. We have only the one that we have created by copying the load case. Creep 50 years. Okay, now from here our job is has started. Okay, so it is the duration. So 11 means up to 11 floors it has given. So this 10 and 11 floor is nothing but our Mumpty room and the LMR room, right? And this timing is the curation day. How many days you will be keeping for the curation? Sorry, the curing day. Okay. So first of all, we will set up some stages up to 11 that we have completed the construction of the structure up to the 11th story. This is the story level, right? Now we will add some more. Add, suppose 1 year. I'll name it as 1 year. Now after 1 year, what will happen? Means after 1 year of construction, what will happen? After 1 year of construction, you can consider that the total building will be occupied by the people who will be living there. So some extra live loads, the live loads will be coming. So you can divide these live loads in different parts. Suppose, now this is totally about the project management or about the project manager. He will be telling you like how many days it will take. Maybe it will take 2 years to occupy this full building. So what you can do, you can use the 50% of live load at first 1 year, and again you will add rest of the 50% after 2 years. Okay, so here for the ease of our understanding, what I'll do, I'll occupy this building 100% or maybe 80% after 1 year. Okay, so then we will, after 1 year, we do not need, will not add any load. We'll see like now the aging of the load, like load is already there and the time is spending, right? We'll be spending the time on it. Okay, so there will be some deflection, permanent deflection of the on the building. Okay, so now I'll give it as 10 years. The duration I have not set it. Okay, just I'm writing the names. 10 years, add. Okay, it will be 20 years. YEARS, 20 years. Now it will be 30 years, 40 years, and add again, and it will be 50 years. Okay, 50 years. Fine. So we have defined. So now the curing days. This first stage, the stage 1, comprises of the base, that means the foundation level, and the first story of the structure. Okay, now how many days you will keep? How many days you will keep for the both? Okay, so in general, what you can do, you can like exactly we should go for 28 days, right? So in this kind of structures, or maybe the structures who are constructed by the promoters, they may not keep that many days, but still here now this total definition you will be getting from the project manager only. That's why this kind of analysis is not done in small structures, only in the tall buildings or maybe major projects. Okay, so all the durations, this first one, as we do not have any base level, okay, we do not have the foundation modeled here, so though we have this level, will not consider. I'll keep it 28 days only. Okay, 28 days. Now I'll keep everything as 28 days. 28, 28, 28, 28, 28, 28. It might be 14 days also. So depends on the project and the project manager. 20. Sorry, not here. Not here. It will be, make it 0 only. Okay. So this is up to the build. These two stories are my LMR and my stair room, right? So they may not keep this as 28 days. Small part of the building, right? So maybe 7 days or 10 days, something like that. Okay, so for now I am keeping everything as the similar. And now the construction, they have done the construction. Okay, the first stage, let us take it 56 days, because though we do not have, so it will not consider, not an issue. So now 1 year. Okay, so 1 year means after the construction 365 days. So 365 days. 10 years means after 1 year again 10 years. So 3650. 3650. 20 years means after 10 year again 10 year, right? So again 3650. Same after 20 year again 10 years. So 3650. 40 years same, again we have added 10 years. So 3650. And 50 years we have 3650. Fine. We have kept this duration days. Now we'll go to stage operations. Okay, so we are in 50 years. First of all, we'll come back to the first operation. In the first operation, you can see there are 2 levels which will be added. Along with this, the self-weight of these levels will be added. Okay, now the scale factor 1.5 we have considered, because there will be cranes, the people will be working on this. So that's why I have considered a higher scale factor here. Okay. So now the ages, we have considered 56 days for the first one, right? Though we do not have any foundation, so we'll be considering as 28 and 28. As we do not have any foundation model here in ETABS, it will not an issue. But if you are doing soil structure interaction, so you will be creating the foundations also here after getting the foundation design from SAFE. Okay. So though it is not our syllabus, it's okay. So 28 days. Now next. So now only one story, which is ground floor, 28 days. Next 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 28 days. Terrace 28, as we have considered 28 only, LMR 28. Now if you are going to first year, okay, LMR top up to LMR top, right? So you have taken 28 days. Now we are in the 1 year, first year. First year, as it is created by ourselves, though there is nothing, right? So in the first year, once after the construction of the building, 1 year, what will happen? There will be no addition of structure. There will be only addition of the load. So what load we will be adding here? What load will be adding here? Add here, and it will be load objects if added, and we will add the live load less than 3, right? Because we do not have any live load greater than 3. If you have, you can add this also. Load objects if added and live load greater than 3, but we do not have any live load greater than 3, so I'll keep only 1. Okay. Now if you want to consider only 80% of the, maybe say 50% of the people will be coming, occupancy of the building will be only 50%, so the skill factor will be 0.5. But what I'm considering that after 1 year only the total building will be occupied, so that's why I'm keeping this live load scale factor as 1. Okay, this is after 1 year. After that you do not have to add any load, because we just want to spend the time with the load that we have added. We just want to spend the time with the load we have added. Okay, so we have just added the time here. Okay, so now click on OK. You can see here. Now this particular analysis is a non-linear analysis. Okay, this long-term effect you can only find in non-linear effect of the material. Okay, so that's why we need this material property are time dependent. We need to consider the material property as time dependent. Okay, so check this option. Now click on OK. Click on OK. Save this. So what we have done, we have asked the software to consider the time dependent property of the material. But the material that we have defined, this is only a linear property. So we'll go to define section material properties and M25. Modify this. So these are the linear properties of the M25 concrete, the concrete. But what we need the time dependent properties. Okay, so we'll click on this time dependent properties. Check this creep and shrinkage. Okay, so this creep and shrinkage will be added as per the code that we have selected here. You can see here we have CEB FIP 90, we have CEB FIP 2010. Okay, so it is the updated one. You can go with the 90 also. I'll check this one, CEB FIP 90, which is the mostly used. Okay, otherwise you can go with the CEB FIP 2010 also. I do not know actually. It is better to go with this one, which is the mostly used. CEB FIP 90. These parameters are taken from this code only. If you want to see the plot for the creep, you can see this is the plot, or this is the graph that we have in the CEB FIP. Okay, code. With the time, what is the creep? I have told you, right? So this value, what we have done, we have considered 2 to 3, like 2.5 is yesterday, right? So now it will be considering the exact value that we have for M25 grade of concrete or the concrete material. Okay, so now we do not, just you can check here what are the values. Done, and click on OK, and click on OK. Now save it. Now run the analysis. So it is a long process actually. We need to practice it again and again. Then only we can get this. And now it will take time because we have considered the time dependent property. It will take some time to. Here you do not have to do the scaling and all because we are not going to check the earthquake forces. We will just consider the dead load and live load to check the deflection of the structure, right? So scalings and all are not important here. See this creep 50 years load, it is taking more time because every step it is analyzing now. I don't know whether I have done some mistake or not. Let's see. Because it is a long process analyzing this. Now the effect you will not that much like you will not find that much difference in the value here. But what I'll recommend you to get the actual or to see this visually properly, you just create a 2D model in ETABS, maybe 2-story like this. Okay, one building like this, and the same just make a longer grid, and another building like this. With same spacing and all, just remove this particular column. Okay, and these two beams will be combined. Maybe it will not be combined because there will be a graph, grid. Yeah, I think I have done some mistake. I was thinking about it. Let's see. Load case 50 years. Load was specified to be applied on the elements only, but only elements are being added. So the load will be 0 in stage 12 of case 50 years. Stage 12. Yeah, I think I have done some mistake. Let me check one thing. Define load cases. I think in the 1 year I have done the mistake. The stage 12 is 1 year, right? Yes, here. So what I have done the mistake, I think it will be load objects. It will not be load objects if added, it will be load objects. Click on OK. Now it will be OK. Run the analysis again. It will be load objects. I was also thinking maybe I have done some mistake there. Load objects if added means if any object is added there, then only the load will be considered. I guess, yeah, this was the mistake actually. So yeah, what I was talking, like you create a 2D frame with a middle column or without this middle column, and then do the same process for just assign a UDL on the beams. Okay, and use this particular process that we have done here. Okay, so you'll see the deflection in the beam in this first case and the second case, and you'll understand the actual behavior. So whenever you are doing a 2D analysis, remember here I'll show you. Just let us finish this. whenever you are doing a 2D analysis, you need to tell the software that you are going for 2D analysis, not 3D. Okay, I'll show you where. among 8 members, we have only 4 members. Like every day we used to have like this only, right? 4 members only, whatever. See, these classes is only better in live, actually, live classes. You are seeing in recorded, pre-recorded, sometimes, yeah, if you have doubt, you can ask me always, but still, maybe sometimes, because all of our working professionals, so we hardly have time to sit somewhere and see the classes. Okay. Why we are getting this value? Load was specified to be applied to added elements only, but no elements are being added. So the load will be 0, the stage 12. I think it has not changed. Let me unlock this. Define cases. Structure will not be added. It will be load objects only. Yeah, load objects. Okay. 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 Let me make this faster. Okay, what I was telling you, whenever you are going for 2D analysis, you need to change this to 2D here. Actually, here you can see XZ plane or YZ plane, whatever plane you are selecting, you need to select from here. Or for 3D, you need to select this full 3D. Okay. Let me make it faster. Multi-thread solver. Okay. If you are using a gaming lappy, it is a like plus point for you. You can change this to gaming mode and use the multi-thread solver. Actually, we have different solvers in ETABS. So if you are using the multi-thread solver, it will be way faster than the process that we are getting initially. Yeah, now it is fine. Actually, I have not unlocked this, and that's why it was showing there. So now to check the construction sequence analysis, what you have to do, just go to deform shape, select the load case as creep 50 years, right? Now you are having this step. So the deflection will be along Z direction, use Z, click on apply. So you can see this is the first stage. If you click on, now you can close this, you do not need this. You can see this is the first step out of 29 steps. Now here this arrow, we have 2 arrows, click on this. So you can see there is no change because in the first step we had two levels, right? The base and the top. So that's why there is no change. Now if you click on next, so one more structure added, click on next, the loads will be added. Next, one more floor added, the load will be added. Next, like this you can see how the deflection is coming. How amazing it is, right? The total process you are seeing like here. So we have added the there is, sorry, the bumpy level, load, now the LMR level and the load. Yeah, yes. Now, so we have completed the construction. Okay, now it will be after 1 year. Okay, after 1 year, the live loads are added. Now that we'll be spending the time 10 years, 20 years, 30 years, 50, 40 years. No, I think in between there were something else also, because I have missed something. 28. Now it will be the end, 50 years. Okay. Now you go to the plan view, and here we have got, you do not have to check using that the method we have checked previously. Okay, if you go down where you have got the maximum, I think here, so it is 32.575 mm. Okay, so yeah, this is the maximum value. This is the maximum value, 32.575 mm. Okay, with consideration of creep and shrinkage. Now unlock this, see this slab, unlock this slab, right? So this is the shorter direction. Let's check draw dimension lines. 5.15. Let's see, 5.15 divided by 5150 divided by 350. 14 mm. So the limit is 14 mm. We are getting, what was the value that we are getting? 29 stage. We are getting 32. So obviously we need to change the size of our slab. Okay, we need to change the size of our slab. We need to make it maybe what, 150 mm. Okay, so we need to make it 150 mm to get the actual result. For other cases it is, yeah, 30-35 mm like this. Okay, so yeah, it is better to make the slab as 150 mm only. Let's change it, define section properties, slab, and this 130, right? So we'll change it to 150. 150. So it is not required for this structure, because for the deflection, for slab deflection and all, we are not checking all these things. Only for the girder deflection and all, we used to check using this option. But just for our convenience or to understand the process, I've increased the size. Because maybe after design, these beam sizes will be increased. Okay, the column sizes will be increased. So obviously it will be oh, okay. So what I have not done, sorry. Cancel it. I have not checked the axial shortening. Sorry. Let's unlock this. I have not checked the axial shortening. Assign, define, section properties, slab sections. Let's make it 130 only. 130. Because the value that we are getting, it was total deflection, including the axial shortening, right? So we need to check the axial shortening also. The process, total deflection, total minus axial shortening will be there. Axial shortening will be there. Just we do not have to multiply the creep coefficient here, because this axial shortening is added, right? We are seeing the total deflection of the structure. So what is the deflection or shortening of the column? We need to check. This thing we have skipped. That's why maybe 32 values are coming. So the limiting value is something around 14.7. You can say 15. Let's see. We need more time to complete this course. school courses only because every time I do not take any project that I have already done. All the time, even in the previous batch also, I have taken a model that I have not done. So I was doing here itself with all of you. In that case, what will happen? Whatever the problem that we are getting, will be solving together. Otherwise, what will happen? I already know the problem. So what I'll do, I'll just take those measures without doing the trial and error. So the process, the people will not understand. That's why I should take a model which is raw totally for me. I think it is a better approach. I don't know if sometimes maybe people feel like it is boring, but this is the better approach to learn actually. Otherwise, I might have taken a simple rectangular structure, maybe 100-story, but doesn't matter, right? If you are taking a rectangular structure, even it is a 100-story, that doesn't matter. You will not get any rotation, you will not get any problem in that. Easily you can do this. Yeah. So what I was checking, let me go to the last step, which is 29. Apply. So we are getting 32, and where we have the column, the nearby column of this one, any column we can check actually. Maybe this one I'll be checking, or this one. So I need to check this 2 points. 32 we had. Apply. At this point we have 15. At this point we have 16. Okay, so any one we can consider. Maybe this one, 15.78. So 32, and what is this value? 15.78, right? This value is 32.57. So 32.57 minus 15.78. What is the value we are getting? 32.57 minus 15.78. So value that we are getting, it is something around 16.79. Okay, so we are getting a value of 16.79, which is almost closer to the 15 mm. Okay, so do not, as I have told in the previous class also, in that case, if you have this much of difference, you do not have to change the size. Okay, because obviously whatever beams that we have provided, we may need to increase the size of the beam in case of the design. Okay, so and maybe the column size will be increased, the beam size will be increased. Okay, so in that case, if you are making all the slabs 150 mm, it is not required, right? Because the difference is very less, maybe something around 1 mm. Okay, so even in yesterday's class also, we have got some difference of 1 mm, right? 1 to 1.2 mm. Is it the correct one? Okay, 16.8. Yeah. So you can see the result that we have got. The result we have got, it is almost similar to the result that we have got yesterday. Okay, the difference that we are getting also, this difference also, it was same that we have got yesterday. So in such cases, construction sequence analysis will give you, this is means you are taking the exact result, but the problem is it is taking more time. Like you need to define all the things, so you need to do the whole process again and again. Okay, so that's why you can go with the process of multiplying the creep coefficient for such structures. Plus, whenever you have transfer girders or transfer beams, it is compulsory to go with this construction sequence analysis. Okay, so is it clear how we can do construction sequence analysis of a structure? Is it clear? We do have the same thing for the bridges also, construction stage analysis, which is very important for the bridges. Maybe mostly the bridges with girders, precast girders. Okay, so this construction stage analysis is very important for those. Is it clear to everyone? The process, how we can do the construction sequence analysis, and what is the need? Okay, so yeah, let me save this now. So you can create one model. You can create the same model and you can show me how we have done the construction sequence analysis and what is the result you are getting in your structure. Okay,